Radicals. We're going, a radical is any expression with a square root or a cube root, etc. So square root, they write like this. A cube root, they write like this. A fourth root, they write like this. We mostly do square roots. But in the upper levels, you know. And actually later on, I believe we get to cube roots. It'll be an adventure for all of us because I haven't looked that far ahead in our own curriculum. So, the radical symbol is just the square root symbol. Technically, a square root has a 2 here, but because it's so common, we don't write the 2. We just assume that if the 2 is not there, that's what we're doing is a square root. It's kind of like how on default everything is to the first power. And since that's so normal, we just don't write it because that would be really annoying if you had to write the first power every time. So here with the square root, it is so common, we just don't even put the 2 because that would be obnoxious. So I'm going to go ahead and erase that. Okay, but third root and fourth root, those are not nearly as common, so we actually do put the 3 and put the 4 to differentiate between them. Okay, so radical symbol is that. All right, first 20 perfect squares, that's way too many. We're not going to do that many. Okay, 1 squared is 1, 2 squared is 4, 3 squared is, 4 squared is, 5 squared, 6 squared, 7 squared, 8 squared, ooh, that one was a little bit more hesitation, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, there we go, 14 squared, 196, 15 squared, 16 squared, 256. That's as far as I know. What's 17 squared? I didn't know that one. Okay, we're going to be rebellious against Gina, and we're going to stop at 17 squared because she said 20. I don't even want to get there. Anyone know what 20 squared is? 400. I know I was saying it cool. That's how all the cool kids say it. Whoa. Sophie said, okay. That's funny. All right. So square root of 49 is what? 7. Easy peasy. Square root of 225. 15. Okay. Square root of 144. 12. So that means that we have 2 multiplied by 12, which is 24. So this is just 24. Okay. Now, for a problem like number 4, we're just going to split the fraction. We're going to split the top. We're going to split the bottom. So we're going to say this is the square root of 4 over the square root of 9. Oh, that's not so bad. The square root of 4 is 2. The square root of 9 is 3. Okay, now when you take square roots, a lot of times you do plus minus, right? We've learned that in the past, that square roots have a plus minus. The reason we do not do that in this case is because we did not take the square root, right? It was already on the paper. Everyone agree with that? The square root was there before we even got started with the problem. So since they are the ones who did the square root, they are the ones who determine if it should be plus and minus, or if it should just be plus, or if it should just be minus. Does that make sense? They decide. If we are solving a problem and we are the ones who are doing an equation and we square root both sides, then we have to say plus minus. You got to have both answers. But if they are the ones who introduced the problem, then they already determined it should be the positive answer, it should be the negative answer. So here they said positive square root 4/9, so the positive is the only version we write. Does that make sense? If we do the square rooting, we put 2 answers. If they do the square rooting, if it's on the paper already, we go with what they say. Does that make sense? Okay. I will repeat that as many times as you need. So if you forget later, just ask me to repeat it again. Sound good? Okay. I'm going to skip 5 and 6. I feel like we can handle those, but let's look at 112. Some teachers do the like find the perfect square in the number method. I am not a fan. I love me a good old factor tree. How do you guys feel about factor trees? Have you heard of them? Of course we've heard of a factor tree. So here's a factor tree. 112 is divisible by 2. Would you agree? Yeah, okay, so it's 2 times what? 56? Marvelous. I didn't even do this ahead of time. I was like, I'm going to let them be my calculator. Is 56 divisible by 2? I usually do 2s because they're easy for my brain. It is 2 times what? 28? Okay. And then since I broke down the 56, I'm going to go ahead and just kind of cross it out lightly so that it doesn't distract me in the future. Okay. 28. If I look for what multiplies to 28, what are numbers that do that? 4 and 7. Okay. And now that I broke down the 28, I'm going to kind of lightly cross it out. All right. And then does 7 break down? No, does 4 break down? Yes. What is it? 2 times 2. And now that I broke down the 4, I'm going to lightly cross it out. Okay? That is something that I picked up, the crossing the numbers out is something that I picked up because I kept getting answers wrong. That's not something normal teachers do. It's something that I do to not get answers wrong myself. Okay. So what I do is I circle pairs. A pair of 2s, a pair of 2s, and then I have a leftover 7. Your pairs go in the front of the radical when you simplify. Your leftovers go underneath. Okay? So this is how it's going to work. We have a 2 and a 2. We have 2 pairs of 2. Okay? So I'm going to say 2 times 2 is 4. And then I'm going to say square root 7. Okay? Here's why it works. I'm going to tell you why it works, okay? Because basically what we have here is we have the square root of, this is 2 squared, times the square root of 7, times the square root of 2 squared. Would you guys agree with that? Square root of 2 squared times the square root of 7 times the square root of 2 squared. Do we see that? Let me zoom in. Well, let me zoom in so you can see it real good. So we circle our pairs because that means 2 times 2 is 2 squared, right? And then we had another pair of 2s, so that's 2 squared again, right? And then I underline my leftovers because that's not a pair, so that just gets written by itself. Now, what happens when I square root a squared? It's just 2, right? Square rooting a squared, that cancels, we just get a 2. That cancels, we just get a 2. Does that make sense? So that's how we get 2 times 2 is 4. That's why the 4 is not underneath the square root. The 7 did not have a pair, so it did not get written as 7 squared, so the squared did not cancel out, so it stays underneath the radical. Ooh, does that make sense? Okay. So basically, the shortcut is circle your pairs, take the number from the pair and just multiply them together. That goes out front. Whatever is not in a pair gets underlined. That goes underneath. Okay? All right, 245. Let's try a tree again. 245. Now, if you like the method of looking for perfect squares that are in the number, that is fine. I have found that students have a hard time with that, and sometimes if they have a hard time with it, they just skip the problem and move on. But everybody can do a factor tree. Everybody can go, oh, that's even, it divides by 2. Everybody can go, oh, that ends in a 5, it divides by 5. Does that make sense? So I like the factor tree because it might be a little bit more time consuming, but it is equal opportunity. All of us can do it, right? Okay. So this one is 5 times what? 49. Ooh. And then 49 is 7 times 7. Okay, so we have a pair of 7s and a leftover 5. A pair of 7s and a leftover 5. So we're going to write this as 7 root 5. The reason that it works is because we have the square root of 7 squared times the square root of 5. That's why it works. Here's our 7 squared, and there's our 5. The square root and the squared cancel each other out. And that's what gives us just the plain 7. Mind blown. My mind is blown. All right. I have a cat hair, like right on. There we go. Sorry about it, guys. Figured it out. I figured it out. All right. Let's do 578 because that's a big number. All right. How should we start it? Divide by 2. 2 times what? 289. Oh, 289 is a perfect square. I don't like when they do this. I was hoping it would be like a big old factor tree. I only recognized 289 as a perfect square because it was on the list we just found, not because I actually knew that ahead of time. So what is the square root of 289? 17! Gina, why you do this to us? All right, so we've got, if we simplify just the radical, so I've still got the 3, but if we simplify just the radical, how do we simplify just the radical? Okay, so then we have to take the 3 that was there. We can't forget the 3. And this is 3 times the radical, so we're going to say 3 times 17 root 2. And what is 3 times 17? 51. So 51 root 2. Okay. I believe it's a one-sided worksheet. So are there any more questions on here where you're like, Miss Rice, you went over some examples, but you didn't do something like that? Are there any, or do you feel like I've done enough of the examples that you could finish the rest of the worksheet? No, we're going to do it right now. I mean, if you don't finish it right now, yeah, you're going to take it home. But I'm going to give you some time. Okay, you guys feel like we did enough examples, you can finish these? Yes? Okay, so go ahead and work on that. You found it for us. Number 9! Number 9, we needed to do this one, Macy. Thank you for that. Macy drew my attention to it, and I saw exactly what she was talking about. Macy, I read your mind. Did you like it? All right. Break down 72. Ooh, I heard both. I heard 36 and 2 and 9 and 8. What would we rather do? 9 and 8. Let's do 9 and 8. Ooh. Jack, do you feel salty for being rejected so early in the morning?
No, you did not. No, I said 36 and 2, but then I was like, oh, probably 9 and 8.
Well, that's fair. I mean, they will both accomplish the same purpose, but I like this because it's like a tree that is very healthy because it's got lots of branches. You know what I'm saying? It's like a very branchy tree. All right, 9 is 3 and 3, and then I'm gonna. All right, and what about? Did you like that sound effect? Okay, and then what about 8? 2 and 4. Okay, and then we're gonna. Okay, and when you do it, you have to make the sound effect. So I expect that next time. Okay, and then what about 4? 2 and 2. Okay, don't forget the sound effect. Okay. Now, this is an interesting one because this is where I read Macy's mind. What happens if you have 2 pairs and they're different numbers? You multiply them together, okay? Now, the same thing would happen. Let's say we had, because so far we've only had examples that had only 1 leftover number. We haven't had any examples that had 2 leftover numbers. But if you had a problem that had more than 1 leftover number, you would multiply the leftover numbers together as well, okay? So if we had a leftover 2 and a leftover 5, that would give us 10 underneath the square root. Does that make sense? Okay, so 3 times 2 is 6 with a leftover 2. That's 6 square root 2. Now that is just the radical. So what do we need to do to completely finish the problem? Stick the 5 in the front. So we got 5 times 6 root 2. And what do we get? 30 root 2. Marvelous. All right, I'm going to give you guys some time. All right. So first thing we do, just like factoring, is we make sure it equals 0. So number 1 is ready to go. Number 1 is ready. All right. So Our A value is 1. Our B value is 2. Our C value is negative 63. I am assuming, since we've done this before, that I don't need to like color code things. You can color code things. Do I need to? Would that be helpful? I've got markers. Oh, I've got markers. My heart doesn't really desire it because it's a lot of switching. Okay. All right. So the quadratic formula is x equals. Oh, guys. So in Oregon, which is where I'm from, you do not pump your own gas. There is somebody called a gas station attendant who pumps your gas for you. Yes. And one time, I used to go to the same gas station all the time on my way to work because it was like right off the freeway. And the same guy, who was years younger than me, would always pump my gas for me. And he would like ask me questions about myself. Like it started like, what's your name? What do you do? Oh, you're a math teacher. That's very cool. You know, like different things. And so once he found out I was a math teacher, he started trying to like up his like hitting on me techniques using math things. But he did not know very much about math things. And so one day I showed up at the gas station and he started singing the Quadratic Formula song to like Pop Goes the Weasel. Like negative b, plus or minus square root, plus or minus. He started singing. So I was sitting there in my car, filling up my entire gas tank. It was on empty. As this much younger boy sings to me the Quadratic Formula song. No, he sang it right. And I said, thank you. Oh, I am sure he did. I never pumped my gas before work again. That is not the right way, even if somebody likes math. That is, I mean, that actually could maybe work for the right person. But that was not the way I wanted. If you are a gas station attendant in Oregon ever, do not hit on a woman that way. Or a man. An equal opportunity. All right, let's move on. Yeah, please don't do that. I was like, well, I'd like to end this awkwardness by driving away now. Bye-bye. Yes. Yes. Yeah, that's when you know. So we got negative b plus or minus square root b squared minus 4 times a times c. All divided, yeah, the double negative is a good sign. All divided by 2 times a. All right, now I don't know how your last year's teacher taught you to like simplify things, but what I like to do is I use my calculator for this part. Anyone remember what this part is called? Starts with a D? Discriminant. Okay. So negative 2 goes up here, positive 2 goes down there. And then right in here, I'm going to plug in the whole discriminant. Yes, Nate. Yes. 2 squared minus 4 times 1 times negative 63. That was Nate saying, please, let's get back on track. I would appreciate that. All right, what is the square root of 256? 15. No, 16. Sorry. You might have said 16 and I just misheard. So we got negative 2 plus or minus 16 divided by 2. We got 2 answers. What is negative 2 plus 16? 14. 14 divided by 2. Okay. Negative 2 minus 16. Negative 18. Negative 18 divided by 2. Negative 9. All right, anytime we get answers like this, it means that the problem was factorable. You get nice answers, that means the problem was factorable. If you get a decimal, it means it was not factorable and the quadratic formula was the way to go. Yep. All right, let's try the next one, shall we? All right, 6x squared, negative 11, x, negative 10. So I got a equals 6, b equals negative 11, c equals negative 10. So x equals negative b, so I've got the negative of negative 11. Ooh. All right, now we have to be careful here because baby otters are on the line. We do not say negative 11 squared. We say parenthesis negative 11, parenthesis squared. Or else a baby otter dies. Dun dun dun! So this has to be in parentheses, or else a baby otter dies. All right, minus 4 times a times c, all divided by 2a. What's a minus minus? Plus, we got 11, we got a 12, okay, and then let's find our discriminant. Negative 11 squared, making sure I don't kill that baby otter in the calculator. So I didn't kill it on my paper, but I'm also not going to kill it in the calculator. I mean, it's still killed, though. It's still dead. All right, so anytime we see a radical that is not a perfect square, we got to try to factor tree it to see if it can. So can we factor tree this little guy? 361. It doesn't divide by 2. Now, let me show you a trick. 361 divided by x. Miss Rice, we've already done that. I know, but it shows you the factors. Decimal, 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 decimal. It appears 19. 19 times 19. Yes, you could have tried the square root of 361, but I didn't think it was a perfect square. I don't recognize the perfect squares that high. I thought maybe it would break down with the factor tree. Actually, this is a good point, though. If you're doing a factor tree and you can only get 2 numbers that are the same, that means it was a perfect square. You're like, Miss Rice, what happens if I only have a pair? Then you get 19 and there's nothing underneath your square root, and so you go, oh, it's just 19. Interesting. Interesting. So it was a perfect square. (11 plus or minus 19 over 12). All right, 11 plus 19, not 20, 30. 30 over 12. 11 minus 19. 11 minus 19. Negative 8 over 12. Can those be reduced? Negative 2 over 3. Okay, and then this one can be divided by what number? 6. Okay, so it'd be 5 halves. Marvelous. So these ones, this could have been solved by factoring as well. It would have been a slide divide problem. A slide divide problem. Because that's what we're practicing today, silly.
Do you ever really have to do it?
So the thing about the quadratic formula is it always works. The thing about factoring is it only works if it's factorable. So that's kind of the nice, that's why we're practicing this today, is just to show like, oh, hey, we could factor these ones and we can still use a quadratic formula. And then we'll get to some other ones where we go like, oh, we could not have solved that by factoring, but with the quadratic formula, we still can. Yeah. All right. Okay, hold on, we're going to pause. I don't know how long I paused that for. Just tells me which one to do. All right, we're going to do 10. 10 is next. All right. Now, I think Miss Gina Wilson is making a point. Have you noticed that we keep having the obnoxious negative on the bottom that is kind of annoying to deal with? If you want to avoid that negative on the bottom, what you can do is avoid having your x squared term be negative. Okay? So if you don't like dealing with that, if it's making you uncomfortable, then just keep the x squared term positive always. Because the x squared term is the A is on the bottom of the fraction. Does that make sense? So if you don't like that negative on the bottom, if it confuses you, then never let it be negative to start the problem, okay? So let's go ahead and do number 10, but let's make the x squared term positive. Now, it's not necessarily a bad idea to just say, in math, when I'm solving a quadratic, I just never let the x squared term be negative. I just always make it positive because it's easier for factoring, it's easier for the quadratic formula. Does that make sense? So if you want to say that's a general rule that I have for myself to make my life easier, that's a fine general rule, okay? It takes a second longer for this because you have to move 2 things over instead of just moving the 8 over, but the rest of the problem, it does make it a little bit easier, okay? So I think it's worth the trouble. So let's go ahead and add the x squared to the other side, and then minus the 10x. And we're going to make the left side equal 0 this time, just to have that positive x squared, because we just don't feel like dividing by that negative number this time. That does not sound fun. So what order should I write these terms in? What goes first? Perfect. Okay, and then you said A equals 1, B equals, and C equals 8. Perfect. Okay. All right, so we got x equals negative b. I am not killing an otter. No dead baby otters right now. Now, you guys don't know Dr. Davis because a lot of you guys are new to being in the high school, but Dr. Davis loves otters. So we are saving the baby otters for Dr. Davis. Also, if you find any leads on how you could own your own baby otter, tell Dr. Davis because she would love to own her own pet otter. She's been trying to do it and has not been able to. So I tell her if she spends more time on TikTok, she'll find it because people own pet otters on TikTok. Oh yeah. Oh, yeah. Yes, they sure do. That is the truth. All right. What do we have in the front? 10, positive 10. Minus minus makes a plus, so that's a positive 10. Okay. On the bottom, we got a 2. Has anyone found their discriminant yet without killing a baby otter? 68 is the consensus. That sounds about right. I'm going to not kill an otter while I verify. 68 is marvelous. Okay. Do we want to factor tree or do we want to calculator and find the perfect square? Calculator. All right, so we're going to do 68 divided by x. 68 divided by x, and I'm doing second graph, and I'm only looking for perfect squares. 17 and 4. All right, what is the square root of 4? Dos. All right, so 2. We got 2 square root 17. Okay. So we have x equals 10 plus or minus 2 square root 17 divided by 2. Okay? And then we cancel the 2's.
No, that's longer than you're gonna kill something. You killed it.
Okay, so we don't cancel the 2's. What do we do? Okay, all of them divide by 2. Oh, thank goodness, we saved the puppies. Oh, thank goodness. It was not a mistake. I was checking you guys. I know how to keep puppies alive. I'm very good at keeping puppies alive. 1, 1, 5. So we are not puppy killers here. All right, we got x equals 5 plus or minus square root 17. Now it's over 1, so I don't even have to put it as a fraction anymore. Okay. All right, here's my exact answer. How do I get my approximate answer? Plug it in. We get our squiggly equal signs. We don't have to have them, but they're fun to write, so why not? 5 plus square root 17. Okay. We're good? We're good. Okay. Do we feel like we want some more practice of this? Okay, so we only have 20 minutes. I think I'm going to give you just some worksheet practice, and I think I'm going to save tic-tac-toe for later. Is that okay? Yeah, so what I'm going to do, let's put an x through 11, put an x through 12. Don't do those. Okay, put an x through 11, put an x through 12. So you guys are going to do the other 5 on this. Actually, hold on. I want us to practice very specific things. So let me look and see what these problems look like. I'm going to tell you which problems to do. I want to practice simplifying radicals. I want to practice decimals. Okay? So I'm going to check and see which ones to do. I might give you some problems off this worksheet, but I'll make it a reasonable amount. Okay? All right.